In this video, we are going to talk about compound interest. So with simple interest, it was interest that was earned one time, but compound interest is a little bit different because you end up getting interest on top of your interest. So let's say you're having a savings account somewhere. Most savings accounts at banks are going to have a compound interest, and the compounding period is going to be a little different depending on what bank you have. So let's illustrate this idea of compound interest. So let's say we deposit $1,000 in a savings account that earned 5% interest compounded annually. So it's going to be compounded once a year. So that first year, we would find the interest by I equals PRT. We talked about that in the simple interest section. So the interest would be $50 for that first year. The future amount of that $1,000 after that first year would be how much we invested plus the interest, which would be $1,050. So that's how much would be in there. And then we're going to do the same thing that second year, but we're not getting interest on just the 1,000. We're getting interest on the 1,000 plus the 50 that we earned interest on. So we're going to do I equals PRT again. And we're going to earn $52.50 on that amount. So then now our current amount would be the $10.50 that we have plus the $52.50 that we earned, which would be $1102.50. And then we could do that again. We could do compound interest on top of that, and then on top of that, and you can see how that compound interest is going to compound pretty quickly. So there's the 1102 that we earned, and then we could earn interest again. So now we earned $55 in interest. So then our amount here would be 1102 plus 55. Oops, 1102.50. I forgot the change there. Plus the 55.13. So we would have 1157.63 in the account now. And you just see how it just keeps growing. It's going to grow pretty quickly because it's compounded. Now, we don't have to compound annually. We can compound different amounts. We could compound semi-annually, which means we would get interest twice a year. We could compound quarterly, which would be 4 times a year, or monthly, which is 12 times a year, or daily, which is 365 times a year. Some banks use 360 instead of 365. So if you're working on problems in the homework system, make sure you check that to see which one they want you to use. So what is our formula? So future amount is equal to present value times 1 plus r over n to the nt. And some textbooks will write it this way. Amount is principal times 1 plus r over n to the nt. Okay, so this is how much you invest initially. The rate needs to be as a decimal. N is the number of compounding periods per year, and time is going to be the time in years. So let's look at an example. We want to calculate the future value of 750 that's deposited into account earning annual interest at a rate of 5% compounded quarterly after 5 years. So we know we're going to use our formula, P times 1 plus R over N to the NT. We don't know the future amount. That's what we're looking for. 7,500 was invested. Interest rate is 5%, which is 0.05. The number of compounding periods is 4 because it's compounded quarterly, so that would be 4 times a year. And time is 5. So if we plug everything into our formula for compound interest, and we would just type this in the calculator, I like to simplify that exponent first. So it's going to be 7,500 times 1 plus 0.05 divided by 4 to the 20th. I'm going to show you how to type that into Desmos. 1 plus 0.05 divided by 4. And then use that Shift 6 to get the exponent. And that's to the 20th. So it would be 9615.28. Now let's say we want to know how much interest was actually earned on this. The amount of interest would be equal to the future amount, so that's our A, minus how much we initially invested. So we would take 9615.28 and subtract 7,500. So 9615.28 minus 7,500 is 2115.28. So that's how much interest was earned in that 5 years by just investing this money and then not touching it. That's what that means. Let's look at another example. Find the interest earned on an investment of $25,000 deposited into an account, earning an annual interest rate of 4.5% compounded monthly over 5 years. So now we're looking for the amount of interest earned. We've got to figure out that future amount first. So A equals P times 1 plus R over N to the NT. Interest rate is 4.5% or 0.045. Compounding monthly, so that's 12. Let's simplify that exponent, which is really just a 60. And then we could type that in Desmos or a calculator. So there's our future amount. So 31,294. Sorry about that. $31,294.90. So then the interest is going to be the amount earned, that future amount, minus how much was initially invested. So $6,294.90. So what I want to do now is revisit this problem, but I want to show you how to use an online tool to help you figure this out. This is a finance calculator, and it's jufinance.com/TVM. It's a time value money calculator. So we've got present value here. We're not going to use payment stuff yet. That would be for like if we take out a mortgage or a house loan. We've got future amount here. We've got the how it's compounded, the number of periods, and then the interest rate. So let's look at this particular problem. So our present value was 7,500. That's how much was initially invested. Our interest rate is 5%, so that's 0.05. We are compounding, in this case, quarterly. I'm going to change this to quarterly. And we were looking at 4 times a year for 5 years, which would be a total of 20 compounding periods. And we want to figure out what that future values amount is. So I typed everything in, and I'm going to click future value and it's going to tell me what the future value is for that. That interest rate, notice here that they've got a percent here, so we're going to type that as 5%. We do not have to turn it to a decimal to use this. I'm going to click future value, and it's going to pop up what that future value is. So 96.1528, and that's the same thing that we got here. So we could do the same thing on this one. In example 2, we were investing 25,000. We were earning 4.5% compounded monthly after 5 years. So let's look at what we would type in. So we have 25,000. Our interest rate's now 4.5%. So I'm going to leave it as a percentage because they've got that percentage sign there. We're looking for future value. I'm just going to empty that out. This is compounded monthly now. And we got to figure out how many periods. So monthly for 5 years. Monthly for 5 years is what that exponent represents. That's the number of periods. So that's going to be 60 there. And then when I click on future value, I'm going to get $31,294.90. So we can use this to help us compute some things. So let's look at present value. Present value, if we rearrange that formula, A equals P1 plus R over N to the NT. We would want to get this guy by itself, and the opposite of multiplying would be dividing. So that's where that formula is coming from for present value. So let's look at an example. How much money should be invested in an account that earns 8% interest compounded daily to have 30,000 in 5 years? So my interest rate is 8%, which is 0.08 as a decimal, compounded daily. We're going to use 365. That's what our textbook's using. We want to have a future amount of 30,000 in 5 years. We're looking for how much we have to invest now. And keep in mind, this is going to be a one-time investment. So our formula was that future amount divided by 1 plus R over N to the NT. So we've got 30,000 divided by 1 plus 0.08 divided by 365 to the 365 times 5. And I'm just going to type that in the calculator. I could do that in Desmos. I'm going to simplify that exponent first. And when I type that in, I got about $20,110.48. Now we would get the same thing using our finance calculator. So this time we're looking for present value, so I'm going to leave that blank. We know the future value is 30,000. Interest rate is 8%, so I'm going to type in an 8 since this wants it in percent. This is a daily interest rate, and we need the number of periods, so it would be 365 times 5, which was our exponent 1825. And then now I'm going to click present value, and we're going to get 30. All right, hold on a minute. Something's not right. Let's try that again. 1825. There it is. $20,110.48. Now, with the calculators, you have to ignore the negatives there. I'm not sure why it's programmed to pop that up. This is a positive amount. That's how much you would have to invest to get that $30,000 in 5 years. So you're going to earn quite a bit of interest on this account. In 5 years, this earns almost $10,000 in interest. Let's talk about inflation. Inflation is an economic condition during which there are increases in the cost of goods and services. Inflation is expressed as a percent. And we can use the present value formula to help us determine inflation. So let's look at an example. Suppose you purchase an insurance policy today that will provide you with $500,000 when you retire in 30 years. Assuming an annual inflation rate of 2.4%, what would be the purchasing power of $50,000 in 30 years? So let's look at what we have. This is our future amount. So that's going to be our future amount, 500,000 when you retire in 30 years. So T is 30. There's our annual interest rate, 2.4%. And we're going to assume it's compounded yearly. Or annually. So that's one time a year. So P equals A divided by 1 plus R over N to the NT. So we've got 500,000. Interest rate is 0.024. And we would simplify that exponent to 30. And if I type that in my calculator, it would be $245,454.67. Okay, now we could do that with that TVM solver also. So let me pull that up so you can see how it would work. I'm just going to delete everything out of my fields. So we want a future value of 500,000 for retirement. This is compounded annually, 30 years, and it's compounded once a year, so it's whatever that exponent is. Interest rate is 2.4%. We're going to leave it as a percentage. We are looking for present value, so I'm going to click that present value button, and there's my amount, 245,000. Oh, hold on 1 minute. Let me try this again. There we go. $245,454.67. You see how that $1 off there changed that extra value changed that. The next thing in this section is the annual percentage yield, or APY. When the interest is compounded, the annual interest rate is called a nominal rate of interest. The annual percentage yield is a simple interest rate that would yield the same amount of interest after 1 year as the nominal rate. So it's also called the effective annual rate. And you hear that a lot, especially with credit cards. So to figure that out, you basically pretend like you're compounding $1 for 1 year. And then you subtract that dollar. And then you turn that into a percentage. So that's kind of the idea behind that formula. Let's look at an example. A credit union offers a certificate of deposit, or a CD, at an annual interest rate of 3% compounded monthly. We want to know the annual percentage yield. So we're going to pretend like we are investing $1 for 1 year. So APY. So I think about investing $1 for 1 year. So if I do that, my P is 1 and my time is 1. So this is really going to be 1 plus R over N to the NT. And that's where my formula is coming from. But then I'm going to subtract, sorry, that T is 1, so it's just N. So then I'm going to subtract that dollar that I invest, and that's going to leave me with that decimal. It's the interest that you would earn if you invested that dollar for 1 year, because we would subtract that initial amount. So let's figure out what that would be here. So interest rate is 3%, compounded monthly, so that's 12 times a year. And then we're going to subtract the 1. And I got 0.0304159 and some change. So it's about 3.04%. So I can move that decimal 2 places to the right to get that annual effective yield. So it would take a simple interest amount of 3.04% to give the same amount as 3% compounded monthly for that year.